Hi all, welcome to the part 2 video of the chapter Polynomial. I am Shambha as your tutor. In the last video, we have studied what is a polynomial and types of polynomial. In this video, we will discuss the exercise problems related to what we have studied in the part 1 video. So let's begin with exercise 2.1. Here is the first question. Which of the following expressions are polynomials in one variable? So, as we have discussed before in the previous video, we are dealing with polynomials in one variable only in this chapter. So, in this question, they are asking us to identify those polynomials that are in one variable. So, in the previous video, we have already studied what is polynomials. Let's recall that. Polynomials are algebraic expressions, right? But those algebraic expression will contain variables, and this variables will have powers that are only whole numbers. So the variables in those algebraic expression will be only whole numbers. So this is what is polynomials. So back to the question. Now in this first question, let's examine each term and see whether the variables have only whole numbers as its power. So here the first term, so I hope you guys remember what is term. This is one term, this is another term, this is the third term, right? The terms will be separated by either a subtraction or an addition. Alright, so here in the first term, the variable is having power 2, which is a whole number. In the second term also, the variable is having a power as a whole number. In the third term, as we have already discussed, this can be written as x raised to 0 because x raised to 0 is 1. So this term is also having a variable with power a whole number. 0 is also considered as a whole number. So yes, this polynomial is a polynomial in one variable also, right? Only one variable is present. X is the only one variable in this question. Yes, so this is a polynomial in one variable. Let's move on to the second question. Similarly, here the variable y contains the power 2, which is again a whole number, right? So this expression is also a polynomial in one variable because we have only one variable, and root 2 is the constant here. Now in this question, this expression is having two terms, right? So the first term, in the first term 3 root t, here the power of the variable t is half because this is square root, right? Square root can also be written as half, raised to half. So this is 3 into t raised to half. Here the power of the variable t is not a whole number. Hence this expression is not a polynomial. Next, here this expression, if you look, it is a polynomial, but then our question is asking us to separate polynomials in one variable. Here in this expression there are three variables, x, y and t. So this, though it is a polynomial, but it is not a polynomial in one variable. So this is also not a polynomial in one variable. In this question they are asking us to give an example each for a binomial of degree 35 and a monomial of degree 100. So let's recall what is a binomial and a monomial. Binomial is polynomial with one term, right? So two terms, I'm sorry. So we must give an example of a polynomial that is having two terms, and the degree of that polynomial should be 35. That means degree means that is the highest power of the variable in that polynomial, right? So any example that you can think of, I am just giving a random example. Let it be 3x raised to 35 plus 7x square. This is a binomial because it contains two terms, right? And then the degree of this binomial is 35, because 35 is the highest power in the polynomial, right? So any random example that you can think of. Now next, the monomial of degree 100. So monomial means the polynomial will have only one term. In that case, we need just one term in the polynomial, and that one term, that polynomial should have a degree 100. So 5y raised to 100, just a random example. So there. Next question is to find out the degree of the polynomial. As we know, degree means it is the highest power in the variable of the polynomial. Let's move on. Here in this expression or in this polynomial, the highest power for the variable is 3, right? So here in this case, this is the degree is 3. In the next question, the degree will be 1 because it's 5t. So t raised to 1. So that is the highest power of the variable. Thus the degree is 1. What about this question? In this question, we know this is a constant polynomial. For a constant polynomial, the variable will contain power as 0. Thus, for this polynomial, the degree is 0. Classify as linear, quadratic and cubic polynomials. So here they have given a few polynomials and they are asking us to classify these polynomials as linear, quadratic and cubic polynomials. So as we all know, what is linear polynomial? A linear polynomial is a polynomial with degree 1. The degree is 1, right? A quadratic polynomial is a polynomial with degree 2, and a cubic polynomial is a polynomial with degree 3. So with this knowledge, let's classify the polynomials. Here in the first question, the degree of this polynomial is 2 because the highest power is 2. So this is a quadratic polynomial, Q. I am naming it as Q. In the second question, the degree is 3 because the highest power is 3. So thus this polynomial is a cubic polynomial. Let me write it as C. In this, the degree is 2. Thus this polynomial is a quadratic polynomial. Again, in the next question also, the polynomial is of degree 2. Thus this polynomial is a quadratic polynomial. Moving on, in this question, this polynomial is of degree 1. Thus this is a linear polynomial because its degree is 1. Here, since the degree is 3, it is a cubic polynomial. Here, since the degree is 1, we name this polynomial as linear polynomial. Linear polynomial because the degree is 1. So thank you guys. Hope this session was helpful for all of you. Please watch the part 3 video of the chapter Polynomials for the next topic, zeros of a polynomial.